All right. Hey guys, so we're going to be streaming the CTF 2021 from Tenable. This challenge was the Friendzone, and I thought it would be fun to hang out with you all and go solve this challenge. So this was a binary exploitation challenge for the Tenable. Yeah, I've already said that. And so let's just get started. Let's basically the challenge would give you the source code. So let's just go ahead and unzip. Oh, this was actually an older challenge. Let's go unzip. Let's unzip, extract this to a directory. Let's just call this source. And let's get all the source code here. It would be cool if, unfortunately, the CTF service isn't up, because what we would do is just simply access this remote binary remotely through Netcat, and we'd see how the application works. However, the challenge only gave us the source code right here, so if we want to do all this debugging and testing, we're have to compile it locally. So let's do that first. That makes the most sense, so we can get a feeling of what the app is about. Let's go to source, and there is no, for those of you who are familiar with C and C++ development, there are no makefiles or build files here for that matter. So we're gonna have to go ahead and make one of those. So one of my favorite build tools is CMake. Let's see if I can show you what CMake is for all of those of you who don't know what it is. Hey, it's in the history here. Perfect. So it's an open source cross-platform family of tools designed to build, test, and package software. So basically with CMake, you can just go ahead and compile C++ source code on any operating system. Doesn't necessarily have to be Linux. You could have CMake and run it on Windows, and it would build you a Visual Studio solution project. So it's cross-platform. But if I run it on Linux, because here I am running Kali Linux, so that's what I do my hacking on. So let's make a CMakeLists.txt file, because that's what CMake expects. And I am going to go and actually cheat here, because I don't think you guys want to be watching me type for the entire live stream. So I do have a CMakeLists.txt file that I used. It was Here, how about we just do this? It was like CTF, Tenable CTF, and then the directory was Friendzone. So I'm just gonna copy like source, CMakeList.txt, live stream, source. Okay, cool. So if we take a look at this, I actually didn't copy it. Or did I? This is just me blabbering on the keyboard. Don't mind me. CMakeList.txt. Okay, so it is here. CMake. Oh, it's because I'm in. There are two directories called source. Oh, that's annoying. That is silly. Okay.
Meow.
Hey, what's going on?
Hey.
What's going on? You're on live stream. You are now live, being recorded.
No.
What's going on? We just started here, so
Cool.
So what you missed is we just had some C++ source code for this challenge, and now we're just trying to build it. And here I am, blabbling in directories, not knowing where I am. But,
I know a little thing about building C++ code.
Sweet. Do you use a CMake?
Not usually.
Just raw makefiles, eh?
Yeah, CMake can make files.
Exactly. So this project didn't actually come with a CMake build file, or even a makefile for that matter. But this is the one that I developed while I was solving this challenge. So basically you have to specify a project. We set the build type to debug, because if you're going to be doing a binary exploitation challenge, you want to have a local runtime environment to debug in. And it's just going to take all the headers and C++ source code and compile it all into an executable called Friendzone. So that's pretty cool. I also like it because it's colorful. Not a really good reason to like a tool, but so just gonna go ahead and make a directory called build. This is where our binary is actually gonna get built in. So we can go here, and if we go cmake ... we go cmake ... because we want cmake to search in the parent directory, which has our CMakeLists.txt file. Let's just do that, and basically it just generated a whole bunch of generated makefile and some other CMake metadata here. The important part is that the makefile is generated. And now let's just do a parallel build with 4 cores. And we take all the source code and build a Friendzone executable. Excellent. So now that we have an executable, let me restate the challenge of this objective. So in the Friendzone, you effectively have a whole bunch of profiles, and you need to read the VIP's profile. The VIP profile is, well, you're not allowed to read it by just using the application. It's forbidden, so you need to find a way to achieve that. So how about we just go ahead and run the executable before we look at the source code. Let's just get an idea for how it works. So let's run Friendzone, and it invites us. Welcome to the Friendzone social media, leader in most advertisements. So how about we go list some users, because that should give us an idea for the kind of profiles that we can read. See if we can find the VIP profile. And we don't have any. So in the challenge came preloaded with data, so it gave us some feedback, whereas here I'm purely just showing you a story locally, but I will have a write-up online that you can read that had some of the data that was on the remote service. So anyways, our objective is to actually load some profiles here, because that's what we need to do. So let's go to do some static analysis since we have the source code. Let's find main first, because we need to find an entry point. So I'm gonna do a grep for main in all files, and here it is, friendzone.cpp. So let's go ahead and open this. So here we create a new console and then we open it. So we should read our console.h or console.cpp. So it's invoking open, look for open, prints the banner, handle root. So basically prints out the Friendzone, just jump into the handler directly. And what does it do here? Display root options, probably don't need to look at that. Actually, yeah, handle root. So display root options, and then it tries to get a command. And that's interesting because in the remote challenge, it actually loads profiles before it even prompts you for anything. So let's take a look at the console header file. So what happens before you even hit open is you construct a console. So there might be some interesting business logic in the console constructor. So basically when we instantiate a console, there's going to be some code that gets executed as soon as it spawns. So we need to find that. And in the implementation, you can just search for console, and the namespace console. I don't see that. Let's see. Maybe it just has a default constructor. Oh. Okay. Yeah. Okay, so it doesn't have it. However, it does have certain items here. Oh, never mind. The constructor is right here. So it's interesting because as a former C++ developer, normally you'd go and define your implementations in the CPP file, which is the implementation. But in this case, the member variables, so like root commands, db, cmd, those were all initialized in a constructor in the header file. So before anything happens, a database gets created. So let's take a look at the database's constructor, because that's the only business logic that could possibly execute from there. Database. So there's no the implementation here. Looks like it's actually in the source file, which is what I normally expect to see. And here it initializes the profile directory attribute to profiles. So that's interesting. And then it tries to load some accounts. Database load accounts. Excellent. So let's see how this logic works, because we need to get a proper runtime environment working before we can even do anything productive with this. So it's basically going to go ahead and open up the profile directory right here. Profile directory is the member variable, so you can access it from any member function like this. And then it tries to iterate through that directory. So, and then it tries to get the name of the current file, and then it prints it. It says loading, and then file name. Well, the full path, the full relative path actually. So it'd be loading profiles / and then your file in that profile, and then say profile data right there. So how about we go ahead and actually, before doing that, it's kind of a good idea to know the format of the data that it's reading, because if you just take a file, you're not really, and the file's empty, then the application is probably going to be confused, because the only data it has to work with is pretty much the file name. So once it gets that, it's going to go ahead and read hex 1000 bytes, load that into a string, and then run some load profile on it. So let's check out the load profile down here. So it takes the profile data, and then it parses the profile data from the string. Well, it actually, yeah, this is the name. Actually, no, sorry, never mind. So the buffer is the contents. Yeah, so it takes the contents of the file and then passes them to parse profile right here. It's convenient how the developer here put these functions right close to each other, which is good. It makes it easy to analyze from a developer's perspective. So basically, we parse a profile and we get a vector of tokens. In this case, a token is a string. So for those of you who are not familiar with C++ development, a vector is basically a dynamic array in C++. So if you have, let's say, 10 items, and then suddenly you need to put more into it, your array will grow to 11 items or more. So basically it's going to read the buffer and try to search for a pipe character. And just kind of skimming over this code, I'm just going to take a guess that it's going to keep looking for pipe symbols, and everything between each pipe symbol is going to be a token that's going to be pushed back into the tokens that we're going to return. So next, the question is, what are we going to do with these tokens? Because this is going to our files are going to represent profiles, right? So if we first look at the processing, we can see that it's taking the 0th item and then using that to determine the profile type, taking the first item to determine the profile name, taking the second item to determine the profile ID. So we got some data there. Let's see what the maximum size is. So far we're at 2, well, technically 3 elements in the profile items. And it looks like we have different types of profiles. So we have a person profile, a business profile, and an advertisement profile. So the person profile goes all the way up to Nine tokens. I say 9 because vectors and arrays in computers always start from 0. And a business profile, on the other hand, is 7. Has 7 items in it. And an advertisement only has 3 because there aren't any extra ones here. An advertisement would only have these 3 right here. Okay, so how about we start with the most complex one because it probably has the most data. Working with that will help our future analysis for creating other profiles. So let's go ahead and create a person profile. I'm going to cheat right here and get because I was able to read the profile during the CTF, I'm just going to be using that data as a flag that we're supposed to capture, and then I'm going to go ahead and fill out some more profiles for you guys. So let's go back to our Tmugs pane here. Let's call this profile creation. So go back to the source, double nested source, go to build. And if we remember, we need all profiles to be in the profiles directory. And this is relative to where your Friendzone binary is running. So let's make profiles. And I'm actually going to copy all the profiles that I had just to save time typing that I did during my analysis while I was trying to do the written write-up for this. Let's see what we got here. Source. Oh. Let's go to profiles. Actually, that's not the one. There was another place where I had more profiles. Live stream source. Write-ups, that's where it was. Friendzone. Okay. Now we're making progress. So we're gonna take all the profiles that I made there and we're gonna analyze them together. We'll put them here. Actually not in the build, we'll put them in profiles. Let's go to profiles. These were the profiles some profiles that we have. So let's take a look at all of them actually. So we'll start out with the Friendzone CEO. So you have, if we break this down, we can see that the profile ID is the 0th item, so profile ID is 0. If we take a look at the profile, what profile ID is supposed to be, sorry, it's profile type, not profile ID. The profile type is a unsigned integer. So an unsigned integer would be is normally used in C++ enums. So if we take profile : person, we can see where that's actually defined or declared in the source. So if we look for profile type, we just search for it everywhere. We can see here that it's in account.h. So if we look at profile type, account.h, we see that that this application only supports 3 types of profiles: person, business, advertisement. Person, in this case, the default behavior of an enum in C++ is it starts at 0. So person would be 0, business would be 1, and advertisement would be 2. And that's why when we go here, this is a user profile, so its ID is 0. Next, let's go back to the database. Next, we were getting the name, which in this case we have Alec. Going back here, we have the profile ID, which in this case is 6. And it's interesting because it uses string to integer, which makes sense because you're kind of reading a string from a buffer anyways. And then it asks you for your address because this is a person type. So I guess he's an unknown address. He wants to keep his privacy. So let's see what 32 is. 32 is the age. And this M would be the gender. And then it comes after the M is the status. So internal Friendzone employees only, that makes sense. And then you have the last post. So the last post is the flag that we need to read. We'll find out very soon that we'll have to do some work to get this. So it only reads hex 1000 bytes from it. So that's very suspicious, because in C++, you might ask yourself, why didn't the author just go ahead and allocate this into a SCD string? SCD strings are safe structures, and they dynamically grow just like C++ vectors. So this is a blink to me. So we'll keep an eye on that. Speaking of blinks, the other blink was the fact that this application reads data directly from your operating system. So whenever you see anything that's reading directly from your operating system like this, you can think directory traversal attacks, where you can just have an arbitrary read on the operating system. So we'll keep those in mind. And so this, because this app might be potentially vulnerable to that class of vulnerability. And then last but not least, we got the add type, which is the 9th element, and I put food. In the actual challenge, it was cars, but we'll see in a second why I put food right here. All right, let's take a look at an example of a business profile. So a business profile, let's go Biscuits Coffee, is represented by 1. And the only difference between a business profile and a person profile is a person profile has an age and a gender, whereas a business profile doesn't. So you have an address, status, and then the post, and then the add type. So type, name, ID, address, status. This is the last post, and this is the advertisement this business is associated with. And if we want to take a look at another user, for example, we have, again, 0. There's nothing too much that changes here, but this user is also associated with the food advertisement. And we'll see that for this example, I only created 1 advertisement. So we'll notice the advertisement only has 3 attributes, which are these ones right here. So profile type, name, profile ID. So the profile type is interesting, and we'll see soon. So, okay. So now that we're kind of familiar with the way how profiles are serialized to disk, and we have an idea for how the application loads them, let's see if we can load this. How about I just call this runtime and static analysis. Let's close all this. Let's go and run the Friendzone. So now it's loading some data. Again, in the actual app, you would connect to directly to the remote instance, and you would find loading profiles, and it would say like Friendzone CEO, Katie Humphreys, Biscuits Coffee, food ads. You could go ahead and use this queue for this loading profiles, and then you could just grab the source code to reverse your way back up the chain. Unlike myself in this demo, I just went through main and then said, hey, how do we get some data here? We got nothing to work with. So clearly this failed on us. We got an invalid add type exception thrown. So invalid add type seems suspicious. So how about we just go ahead and search for this in the code. So let's search for this. Oops. Actually, let's search for that in static analysis. So it's an advertisement.cpp. Let's go ahead and check there. Oops. This is what I want to search for. Advertisement.cpp. So invalid ad type. So it looks like we tried to instantiate an advertisement and it had a bad ad type. So because it had a bad ad type, it goes ahead and throws invalid ad type and exits the program because this exception is not caught anywhere. So let's see what this looks like. So a prevent directory traversal. So it looks like this application was designed with the intent to prevent directory traversal from happening. So that's a security feature. It's interesting because whenever you see security features, one of the things that comes to my mind is how can I go and break that security feature? There has to be a reason why the developer thought about this and put it here. There has to be a very good reason. So this class is quite interesting to me, especially since it goes ahead and opens the advertisers directory followed by the ad type. So in this case, it's trying to read something, and if it couldn't open the file, it returns false. So in this case, the file pointer was null, so it returned false because the file could not be found. All right, let's see what advertisers directory is, because it tried to open it from there, right? So it's not set anywhere here. So it's probably set in the header file. So let's take a look at advertisement.h. And look at that. It's actually, it's set to advertisements. Another blink, whenever you see, again, when you see char buffers in C++ programs rather than the old std string, you're asking for trouble, because whenever you have something like this, you always have to do bounds checking whenever you read any sort of user input that is untrusted. So it makes it more difficult to secure properly. Otherwise you get things like buffer overflows going on. So, okay, we know that there's advertisements here. Then it's going to take the ad type. So the ad type would be the file. So where does that get set? That looks like the ad type is set in its constructor right here when it creates the profile. So let's see how we can figure out what ad type is. Let's have some fun debugging this. So we're going to set a breakpoint on the advertisement constructor and run this in GDB. So go GDB Friendzone. And we're going to set a breakpoint on advertisement. And you can actually hit tab to go ahead and autocomplete, because some of these things are just absurd to remember. So we'll just go ahead and take this. And our breakpoint succeeded. All right, let's run this. So it loads some profiles and boom, it just suddenly loaded the advertisement. Let's go up a bit so you guys can see what was going on. So food ads, loading profile data, suddenly it's constructed. What's cool in debuggers is you can even go and check the backtrace to see how your code actually got called. So you can do BT, which is short for backtrace in GDB. And we can see that it called main created a console, which in turn created a database. And when the database was created, it called load accounts, which called load profile, which finally created an advertisement. Wow. So we're at this line right here. Our goal was to figure out what this ad type is. So we can just go p add type. It's a string, so we can just print it regularly. If it were binary data, you probably want to examine it through hex. And it says food. So if we go back to our profiles and we look at our food ads, it's pretty easy to deduce that this is the input, that this is the file that's trying to read from in the advertisements directory. So now that we come back smarter, we can go create some advertisements directory. And let's go to the advertisements directory, and let's create the food file. For what's a good advertisement for food? Come get the best food. Come get the best food at Tenable CTF 2021. What kind of good foods we got here? We got energy drinks. Energy drinks and I don't want to say pizza. Energy drinks and great food. Okay. Sorry, I'm
sold.
Just having some fun here with the advertisement. Okay. So that's the content of the file. Let's see if this is going to corrupt the file. Or sorry, corrupt the program. So we just have a text file. Let's hit continue, see if we crash. Continuing. Oh, so we didn't crash. I think we're doing good. How about we go ahead and list the users? Hey, we got the profile IDs. So the first one, if we remember, profile ID 6 was this Friendzone CEO. So let's see if we can just go ahead and capture the flag right here and now. Let's go view profile 6. Profile IDs under 100 are marked as private profiles. So does anyone here want to take a stab at what might be a logical step to do next? So basically what I'm thinking is, hey, what if we did an integer overflow or underflow? Because maybe it might just be checking for a particular value that's under 100. But if we try to underflow, then it's our input may not look like a positive number anymore. It'll be negative, and it might fool the app. So let's try -1, just see what it says. So like view profile -1. Second argument must be a profile ID. So we could fool around with this a little bit more. But I know for a fact that for trying this, that this is not the integer underflow or overflow is not the way to go solving this challenge, but it's definitely a logical thing to do. View profile, and then we can just put like something really ridiculously big like this. Invalid profile ID too big, so there is some validation checking as well. And so that's good to know. Let's see if we can actually let me quit out of this for a second, because I want to explain a couple of things first. So let's quit this. Okay, cool. So at this point we've loaded our data into the application. The important part is to never lose sight of the objective that you have at hand, and that was to just go ahead and read the CEO's profile, which was denoted by a profile ID 6 as we saw here earlier. So that's our objective right now. It does help. Like you can just go and search for some common vulnerabilities in the app. So far we've already seen a few. We've seen that, well, they're not quite vulnerabilities, but they're blinks. So we know that the application reads from the operating system directly, so it reads files. And 2, we've seen some C-like buffers, which are dangerous because they can be overflowed if not checked properly. But sometimes something that's could be easier to search for would be any dangerous calls to system. So that's something that I like to look for. It's kind of like once you get remote code execution, it's game over basically. And they're pretty easy to search for. So you can just grep for stuff that has like exec. We'll just do it case insensitive. Or even system. And we'll search for this in the source. And unfortunately, there are no dangerous calls right there. The other thing that you could search for would be string format vulnerabilities. So you look for calls to like printf or scanf. Let's do that as well. So we'll look for some printf, scanf. And we don't see anything there. And if we, even by just doing a quick analysis here, and we just see, maybe we'll look for we go back to console here, where it actually becomes more meaningful, handle root. We go and read, let's say, anything. So it calls getLine, and I believe getLine is a standard C++ function. So if you do like std getLine, we can see that it's a C++ standard call. And usually when you see a developer use C++ calls rather than just C calls, or from like the standard library is pretty safe when it comes to security. So for example, you don't get string format vulnerabilities with things like std getLine or like std cin, and you don't get buffer overflows with std string directly. So right now I'm just getting a high level idea for the practices of this developer, and it looks like they do, based on the little bit that we've seen so far, they are taking security into consideration by checking the inputs, which is going to make our lives as the exploit developers harder. Also as the vulnerability hunters. So yeah, so those were like some quick ones. The other thing you could look for would be cryptography, broken cryptography, but again, don't lose sight of the objective. We need to read that profile ID. So of course we know that there's potentially a buffer overflow here because we saw some, where do we see it? We saw these char buffers. So we could try to figure out a path to try to overflow these, and that might work. But how about right now, let's just do some analysis on the app and just try to understand its behavior a little bit more before we start trying to exploit some buffer overflows here. So let's just go and run Friendzone. It's like a regular user, and gather some more intel on how this app actually works. Because I find that just by running the app, sometimes you can learn a lot about the app just like this, rather than just looking directly at the source code. So list users. We can list users. We can create profiles. We can view the profiles. We can post to profiles, and we can just go and edit them. How about the next logical thing here would be, hey, could we try changing this ID 6 to an ID that's greater than 100? Because last time when we tried to do a view profile, it's telling us that profile IDs under 100 are marked as private. So how about we just go ahead and edit this? So edit profile. Let's try editing profile 6. So it still has access controls on it. You could try fuzzing again for the integer overflow underflow here. Again, that's not the way how this challenge works, so to save time, I'm not going to go and try fuzzing that right here. And if you're unsure, you can save yourself a lot of time fuzzing by just going back to the source code and doing static analysis. So for example, if I want to go look at edit profile, here, root commands edit profile, handle edit profile, you would just search your way through the source code and eventually find how it processes editing a profile. And we can see here that they have a little bounds check, and it also does a lookup profile ID. So the validation is probably in lookup profile ID here. And here it is. If the profile ID number is less than 100, then you get chucked with this error right here. And if you're doing this dynamically in GDB, you could also just set a breakpoint on this function right here. And then you could backtrace this to understand the flow and go back into your static analysis and debug. So, okay, we know that's not a thing. How about we just go ahead and let's just go and create a profile. So we'll create profile. So we're just noodling and collecting some intel. Create a personal profile. What is your name? Username. Rocket. What city? The infamous Pwn Town. Pwn Town was another fun challenge in the Tenable CTF. That's great. What's my gender? Male. What's my age? Over 9,000, clearly. And what's my ad type? So it's displaying. So this is interesting. Finally, what kind of ads would you like to be shown to visitors that visit your profile? Food. So based on the information that we've collected earlier, this application normally tries to go and traverse into directories and then list the contents there. So maybe food is the name of a file in the advertisements directory. So that's particular. What if we try putting something like profiles and then Friendzone CEO? So I'm doing this because whenever you load up the challenge, it tells you, hey, I'm loading profiles, Friendzone CEO. So if we're in the advertisements directory and we're trying to select an item in there, if we go out by 2 and then we go into the profiles directory and then we try to read the Friendzone CEO, we might be able to just read the profile. So let's try this. Invalid, no such ad type. So that's unfortunate. Again, here we could just go and check how this works when you update a profile, but we're just going to skip that for now. So we're just going to enter food just to carry on with understanding how the app works. So let's create another profile. Oh, sure, profile. So this is the ID that was created. All right, let's create another one. So create profile, business. See if this behaves any differently. Business name. Let's call it. Actually, let's call it DC902. Enter your business street number. Call it Leet Street 902. Oh, it's a number. Okay, 902. And then street name, Leet Street. Enter your business city, Pone Town. Enter the state, question mark. Additionally, what kind of ads would you like to be shown to the visitors? Again, this looks very similar to what we just did earlier with the users. Let's just go food because it's probably not going to let us do the directory traversal. Cool. So that we've created 2 profiles, we could go ahead and list them. One thing I find interesting here is there's no option to create an advertisement. Advertisements can only be loaded directly only upon initialization, so only those that have console access to the operating system can just go ahead and create the advertisement profiles. But it doesn't let us do that. So that's suspicious to me. And I mean, if we could create an advertisement, that might be cool. So let's list users. So this is probably this is the business profile. So how about we just go and view this one? Navigate into DC now too, but first an ad. So this is cool. Because the ad that we selected was called food, it actually took the contents of that file and displayed them to us. So it went and read them. And then it has like the rest of the data, the business name, address, status, last comment. One thing you could do if you didn't have access to the source code is you could try fuzzing for buffer overflows for each input here and even string format vulnerabilities. So as most of you know, just the regular buffer overflow, you just send like a lot of A's. How many I cannot say, but by taking a look at the char buffers in the static analysis, that would be a good start to determine the right amount. And you can search for like string format vulnerabilities by doing %p, .%p, just using format syntax, and see if you get weird output and work out the program. To save time, I'm not gonna go through the fuzzing process because we have the source code, so we can just use regular debugging techniques here. Let's take a look at the profile the other profile that we created. See if that works any differently. So view profile. That was the one we just watched. That was what I wanted. Now we into Rocket, but first an ad. So it's the same advertisement. And then it has the rest of the data here. So we've listed a forbidden profile. Sorry, we've read a forbidden profile, or tried to. We were successful in reading the business profile and the user profile. Now what happens if we go ahead and read an advertisement profile, which is this one right here? So view profile 1001. Unable to view account because it's advertiser. There's no profile data to see. If we remember the structures on how these were serialized, this makes sense because a profile only has three tokens in it. So that makes sense why it doesn't have any profile data to see. So can we, how about let's start posting to profiles. Yeah, so post, actually no, let's edit profiles first. Or did we do that already? I want to make sure that I don't do the same thing twice throughout this live stream. Okay, we did edit profile 6, so we know we can't edit the CEO's profile. Yeah, okay, so let's try editing a profile that we can actually touch. So let's try editing the business that we just created. So edit profile, take the business. What would you like to change for DC902? Username or the status? Neither. I don't want to change either. So there's not an option. All right, well, change the username. What would I like? DC9022. And maybe let's try changing the status. Just for completeness. So let's try changing the status. DC902 rocks. And now let's view it. So view profile. Navigating to DC902, but first an add. So it did change the name. We're looking for changes, interesting changes here. And it updated our status. Interestingly, it did not give us the option to update our address or address number. Just to save time for this video, editing a personal profile behaves the same way. So let's go and yeah. So there's one last option we need to test out, and that's post. Actually, no, sorry. We forgot to edit the advertisement profile. So let's do that first. Edit profile 1001. What new ad type should this be? Ooh, what kind of ad? Foobar. Ad type does not exist. So at this point you might scratch your head and ask, like, well, what kind of ad types do exist? Well, we only know that food exists. Food is the only advertisement type. We figured out the ad type when we were deserializing the advertisement profile. So instead of, if we were to say food, that would probably work, but what if we tried doing something like ... profiles and then what's it called? Friendzone CEO. Because this would be a file, right? Relative to the directory. So let's try this. Because that's what we want to read. It does not exist. So it looks like there's probably some sort of directory traversal check, which there is. So if we just go and do some static analysis, we check the advertisement here. And if we try to, we'll notice in the debugger that change ad type, it tries to check if the ad type is valid right here. And then it searches for evil meta characters commonly used in directory traversal, like the dot. This is a forward slash or a backslash. Either. It's a forward or backslash and forward or backslash. It searches for those. So, and clearly we have both of those in our payload, and it would return false. Makes sense. So we'll just go food. Again, I'm saving time here by not running it through debugger. If I want to be really thorough, I would put this through a debugger and show it there. Again, if any of you are interested in seeing that, please let me know and I'll go ahead and do it. So we'll just say food, and that worked. So how about we go and let's post to a profile. So can we post to the admin's profile? No, we can't because they're marked as private. Can we? What happens if we post to the user profile? List users. Let's see if we can. Yeah, post here. So let's post to the business profile. What do we got? What do we like to post? To the DC now to, well, Rocket was here. Now if we view the DC now to profile, let's see what kind of damage we did by posting to it. Latest comment, Rocket was here. Interesting. What happens if we start posting another one to it? So post profile ID 6, no, not 6, but it was this one here. Well, Rocket was not here. And let's view the profile again. I think it was like view profile, blah. And of course, we only see the last posted comment. Makes sense. Just to save time, the user profile is the same as the business profile in this when it comes to sending the post. However, interestingly, if we try posting to the advertisement profile and we just post something to the wall, let's say Rocket was here. And then if we just go ahead and view a profile, let's try viewing the old business profile right here, because that's one we're kind of teasing around. So navigating to DC now 2.2, but first an ad, and this is very odd. We get a 404 no ad found. This is a bug. Please report to the Friendzone support. So this, if we try to connect the dots right here, we're like, well, one, we've finished analyzing most of the options here, and we've realized that every profile, well, the user and business profiles are associated with an advertisement. So after posting to the advertisement, suddenly when we try to read a profile that is associated with that ad, the content of that ad disappears. That's odd. So what could have happened there? It looks like it's probably some sort of memory corruption. So let's see if we want to troubleshoot this. It says, but first an ad. So how will we go search for that here? So grep, but first an ad. I will search for that everywhere. So it's in console.cpp. Let's go to console.cpp, but first an ad. So handle view profile. Okay, so when we read the profile, it tries to read an ad enabled account and tries to read the ad type. Oh, actually, sorry. Let me backtrace a bit. This is not the right way to go about analyzing this. Taking a step back, let's think about what happens when we post to the wall. What happens to the advertisement data structure? So let's try to trace this execution. So what happens when we post? So I think if we go to down here, handle root commands.post, it runs through the handle post option. And then it does its typical checks, right? So tries to take the second token from the command. So that would be the profile ID. You're saying post profile ID. And it looks up the profile ID and there's some validation checks in here like we've seen. So we can't really do the integer overflow. Checks for out of range. And then suddenly we end up here. So what would you like to post to database get profile account names wall? Okay. So it does a lookup in the database, makes sense. And then it tries to get the message from the user input, which can only be less than hex 1000 bytes. So there is bounds checking here, and that's probably because we're writing into one of those C-like buffer structures, and the developer is trying to do his due diligence and prevent buffer overflows from happening here. And then we see some casting going on. So this challenge in its description mentioned there's a really obscure vulnerability. This is actually where it is. So it tries to take the account, it tries to load the account, load the profile from the database, and then downcast that profile into an add-enabled account. So if we take a look at what the database get profile data returns, go to database, there's a get profile data, we see it returns a pointer to an account. And if we take a look at a add enabled account, for example, an add enabled account, like this compiles fine because an add enabled account inherits from or is an account. So an add enabled account inherits all the attributes that an account has and does more. So it's like an enhanced account. It's an add enabled account. So thinking of which, there were three different account types, because when we looked at database and when we load a profile, we had the person, the business, and then the advertisement. So let's take a look at these types of accounts. So I think if it's a type person, it tries to add an account by creating a new user. So let's check out the user file. So user is an add enabled account. So that works fine. That's the expected behavior because, again, we're casting to an add enabled account and a user is an add enabled account. So that's fine. If we go back to, if we try to create a business creates a new business. So if we take a look at business.h, business is also an add enabled account. So that also works. Now here's when things start to get really interesting. What happens when you have an advertisement? Is an advertisement also an add enabled account? Let's take a look. So, advertisement. So an advertisement is not an add enabled account, though it's still an account. So effectively what's going on here is you have user is a add enabled account, which is a account. And then you have the same thing with a business. But then when we get an advertisement, trying to format this so it looks really pretty. Usually a graph or chart would be better, but we're just doing this fast. But an advertisement is directly an account. So that's bad news because when we go back to our console here, it's like, oh, we're gonna go ahead and return an account from this profile. Cool, we have an account, right? But then we try to downcast it to an add enabled account. But the thing is, the profile that we're posting to is an advertisement profile. So there is no add enabled account. So it basically writes to this offset right here in memory. So the last post in what is supposed to be an add enabled account, and zeroes out that memory with 1,000 bytes, and then writes your message there. So how can we use this to our advantage? Well, first off, we remember the blink with the C like char buffers. So when we go to advertisement, we notice that there are two of those here. There's the that text and the advertiser's directory. And almost coincidentally, if we add hex F00 and hex 100, we get a magical number. So if we do like think hex of this plus that, you get the magical hex 1000. So that's almost a sign that the CTF is just telling you to just go overflow those right there. So moving forward, if we analyze this further, we'll notice that if we go into an add enabled account and we try to see the buffer that it was actually trying to write to, it was trying to write to the last post, which in this case, the last post is found at the 0th offset within the add enabled account. So, and that's, I say the 0th offset because the pointer is pointing to that attribute in the structure. So because we're not an add enabled account, we're just an advertisement, what is that doing? Well, that's still writing to the 0th offset in our memory structure, which is the add text in this case. And because these objects were dynamically allocated on the heap, we can overflow this starting from the lower addresses and then spill it up into the higher addresses. So what that means in English is, if you see the code written this way, it's first try to overflow into here, and then anything that spills out from this buffer would end up in here. So now that we kind of understand what's going on there, we should always verify our assumptions through dynamic analysis. So let's just go do that right now. Let's find what line this is. So the dangerous line where it sets the memory is 473 in console.cpp. So we've deduced. So we can just close this right here. And we go to our build directory and we run GDB on the Friendzone. Let's set a breakpoint on console.cpp line, what was it again? Line 473. Cool. So let's just go ahead and run this. And let's just go ahead and post directly to that profile because we want to go and corrupt that advertisement. So post 1001. What would I like to post to this wall? Let's post 8 A's. I just like to post, when I do buffer overflows, I like to put A's because they're easy to find in memory. And they're normally valid characters, so they don't get truncated due to like null termination and whatnot. 2, 3, 4, 5, 6, 7, 8. And boom, we hit our breakpoint as expected. So for those of you who don't know, regular GDB doesn't look like this. I'm using this extension called Jeff, which is the GDB enhanced features. Jeff GDB enhanced features. It's like a Python extension, but it's basically used for exploit development. If you're doing like pwn binary exploitation challenges, I highly recommend this. And even if you're not, it just makes the code a lot prettier and easier to read and go through. I highly recommend it. So in this case, we're not really interested in the assembly code because it's a white box. We have full access to a source code. We have full access to debug symbols. Let's not make our lives more difficult. So let's take a look at what this profile looks like. So what's cool is in GDB you can just go ahead and access this attribute. So we do this and we can see that it's empty. So this null byte here, that would be the here. Profiles. Food ad. Nope. Actually. Whoops. Yes. So this structure right here, the thing that repeats like 3,840 times, that is the add text. So because we haven't loaded any advertisement text, that's why it's set to null here. If you guys wanted, I could just go ahead and load a profile which would trigger the advertisement to get read and fill up this buffer. But for simplicity, we can verify that even by just seeing what the hex value of this decimal number is, and we can verify that is indeed hex F00. And followed by advertisements, which is adjacent to this buffer right here. So that makes sense. And it repeats 240 times with 0 with null bytes. So that's fine right there. We know what's going on. So what happens, let's, I'm gonna hit N to go next, and that's gonna zero out this entire block of memory right here. So we're no longer gonna see advertisements. That's gonna get wiped out with null bytes. So hit N for to go to the next instruction or next line of code, and now boom, it's completely nullified. If we hit N again, we should see our A's filled up in that buffer. So we have our A's right there. All right, so at this point, let's go ahead and see if we can take advantage of this, because now we have control over the advertiser's directory. So if we take control over the advertiser's directory, that means the next time when we create a profile, we can just go ahead and read any file from the profiles directory and capture our flag. So let's, how about let's go and create a exploit to do that? Because, well, first off, we need to generate at least hex. I think it was like F00 bytes of garbage, so that we can get to this overflow point right here where we can take control over the directory. Whenever you do exploit development, I normally just go ahead and write the exploit as a script, because sometimes you have a lot of user interaction, as you've seen with this application here. Like if I go to Friendzone, it loads the profiles, and it's like, oh, okay, well, I have to go post to this profile here, and I post some garbage, and then I have to do another action. I have to go, let's say, view a profile that exists. And you notice there's a lot of manual repetition, and because this sort of line of work can get really sensitive, you want to make sure that you replicate every step very precisely. You can't make mistakes there, otherwise you'll just get confused. So let's do that. Let's make an exploit. So I had an exploit. I'm just going to copy the one that I was working on from my written write-up. So I'm just going to mash on the keyboard a little bit until I find that script that I had, because normally I just go ahead and download a template from a Pwn Tools template and I just modify that, but this I think this video has been going on pretty long, so I'm just trying to save some time here. So go to source, go to build, and let's just go and that's what I want right here. So let's copy the exploit to this directory here. And we should save this for our runtime anyways. Oops. There, this is where we want to go. All right, so let's go edit our exploit. So let's just walk through this step by step instead of writing it all by hand. So first off, I'm using the Pwn Tools library. So Pwn Tools is, let me see if I can explain it here. Come on. So Pwn Tools is a CTF framework and exploit development library written in Python, designed for rapid prototyping and development to make exploit writing as simple as possible. So we're going to be using this. And I believe if you want to install it, there's a documentation that you can read. So basically, context tells you, hey, are we debugging a 64-bit or 32-bit executable? In this case, it's a 64-bit. We set log level to debug because we want to see all the console input that we send to the app and all the console output that sends back to us. That's why I have debug there. We have the process, so we need to know which binary we want to start. And then if you want to do some, if you want to run some GDB commands, you can just put them into a GDB script block right here, and then attach the GDB script to the profile ID. We're not going to be doing that unless we have to, so I have it disabled. And then I say run the exploit with IO as the argument. So basically, we're just going to go ahead and we're going to start the app and we're going to read all the input it gives us until we see a new line followed by the CMD right here. And then we're going to go ahead and post to the advertisement ID of our choice. So in this case, the advertisement ID of our choice was 1001, which is the food advertisement. And then we read some data, the data that the app sends back to us. And here's when we start generating our payload. So this is when we're going to post to the profile. We post hex 0f00 bytes so that we can overflow this structure right here. And then we append profiles because that's the directory that we want to read from eventually. So instead of reading from advertisements, we'll read from profiles. So we can say, so we send the line, we send all this data, and don't forget the null byte here, because when we go ahead and read when the app goes and reads this second structure here, advertisers directory, we don't want to be reading extra bytes in memory unnecessarily. So this keeps it controlled for us. So we send the line, and then we keep reading until we see another line break followed by CMD. So actually, yeah, I don't think we need to edit the profile here. Now I think on the second step here. So let's just go, we're probably gonna comment this out because I don't think we need this right here for exploit. Because we want to create a profile instead. So we're gonna run through the create profile process. Here, this is just confusing. So creating the profile will eventually prompt us for it will prompt us. So I'm just gonna go io.interactive right here, and we can walk through the rest manually, just so I can show that you can read from the profiles directory. So if we go and run this, we can see that it started the binary and it starts reading the standard in. And what's cool is it automated all this manual input, so it's less tedious and we actually go through step by step. So we post, and here's our buffer overflow, where we have hex 0f00a's followed by profiles. And then here we are gonna go ahead and create a profile. So we just fill in the dummy data. We have our name, our city, our gender, our age. And then finally, what kind of ads would you like to be shown to visitors that visit your profile? So it says food. Oh, that was wrong. My bad. I think that's why I had this here last time. Okay, how about we go io.interactive here and take a step back. Interactive. Boundary exploit. Oh. Inconsistent use of spaces and indentation. Oh no. Okay. This should be better. Line 52. There we go. Okay, so let's go and edit the profile. So profile. Let's just go ahead and update the advertisement profile. So what new ad should this be? Let's say the new ad should be, because now we're reading into profiles, right? So let's say let's say foo. Ad type does not exist. What if we said food? Food doesn't exist. The reason why food doesn't exist is because we're now searching the profiles directory. So if we put something like, let's take a look at our profiles here. Profiles. Oh. We have Biscuits Coffee, Food Ads, Friendzone CEO, and Katie Humphreys. So this is the flag. So we want to read Friendzone CEO. And that actually worked. So that's excellent. And then if we just go ahead and create a profile now, let's do personal. It should list that option for us, and we should be able to tie this, which is supposed to be an advertisement type, to the profile so we can read this file. Create profile personal. So username Rocket. What's our city? Pwn Town. What's your gender? M. What's your age? 9001. And now it lists Friendzone CEO for us. So we might as well go ahead and pick that, right? Excellent. So now it's create our profile here. And we can, if we go and view it, we'll see that we have captured the flag finally. Oop. And again, that's because we were able to read directly from the we were able to read the contents of the Friendzone CEO file, and we were able to figure out, we knew the Friendzone CEO file name on the remote instance, because when you connected to it, it would tell you where it was loading the profile from. So that is the challenge. I'm gonna fix the script quickly here on stream because I think it's cool to see it run in its entirety. So instead of doing io.interactive here, we just go and edit the correct advertisement ID. And then we receive data, and then we create the profile, and then we go and view the profile. So let's run this. So Python 3 exploit. So it's going to run all of its input. Oh, did I? Wait, I missed something. I had an interactive somewhere, which is right here. Yeah, let me get rid of that. So interactive. Yeah, we only want one interactive. So this will run the entire exploit and pretty much automates the getting the flag for you. During this challenge with Pwn tools, you can take the same IO but replace the local process with a remote socket, and it would behave the same way. So after figuring out the exploit locally, I just ran it remotely and it worked first try, which was like, oh, that's great. We could go ahead and take this farther. Like, this is just CTF, but in the real world, someone could go ahead and abuse this vulnerability to just read arbitrary contents from any directory. Like, they would first be able to list them by abusing the create profile command, because that would just go and list all the advertisement types that you had. And for each if you had like one advertisement type, you could just go and read the file. But interestingly, I think it only lets you, I'd have to analyze this deeper to see if you can go and list all the files in a directory, but even then it shouldn't matter, because there's certain directories that are standard, like the, what is it? The .ssh directory, where you can go ahead and read private keys. And that's where it becomes where directory traversal becomes really dangerous on operating systems, because these are known naming conventions. These are known directories where you can find content that lets you log into the machine. So basically, you could probably do if you read the private key, you could, and there's SSH open on the box, you could escalate to remote code execution that way through this vulnerability. And so that's the stream. That's the solution. I know this is probably a bit confusing. I was kind of rushed as well, but I will be posting a write-up on my blog and uploading this recording to YouTube if you want to follow through. So yes, I hope to see you guys in the next CTF. And if there are any questions here, I'm gonna stop recording. But for all of those of you who are live in the chat, I'll be happy to answer your questions right now.